What if you could go back and change your biggest regret? That one moment you'd give anything to do over. It's a tempting thought, one we've all had. But what if the laws of physics are telling us that if you tried, you might not just erase your past, you might erase your entire existence? Time travel isn't just for the movies, it's a concept deeply rooted in the most advanced physics of our time. But as we start to peel back the layers of how reality works, we find that the power to control time doesn't lead to some perfect world. It leads to a minefield of paradoxes and possibilities so terrifying they could unravel the very fabric of the cosmos. Today, we're exploring the real physics that might just allow for time travel, and then we'll stare into the abyss and confront the chilling scenarios that await if we ever unlocked this forbidden power. Section 1. The one-way ticket to 1 billion years from now. Before we get into rewriting history, let's start with the kind of time travel we know is real, the kind that's happening right now. I'm talking about traveling to the future. Thanks to Einstein, we know time isn't the constant, steady clock we all imagine it to be. His theory of relativity revealed that space and time are fused together into a single, four-dimensional fabric, space-time. And this fabric can be bent and stretched. Think of it like a bowling ball on a trampoline. A massive object, like a planet, warps space-time around it. The stronger the gravity, the more space-time is warped, and the slower time itself passes. This isn't just a theory, it's a proven fact we deal with every single day. The GPS satellites orbiting Earth are in a region of slightly weaker gravity, so time for them ticks just a fraction of a second faster. If engineers didn't constantly correct for this time dilation, your GPS would be off by miles after just one day. This effect, known as gravitational time dilation, offers a guaranteed one-way ticket to the future. Imagine a spacecraft orbiting a supermassive black hole, like in the movie Interstellar. For the crew on board, only a few hours might pass, but because of the immense gravity, thousands of years could have flown by back on Earth. They wouldn't have broken any laws of physics, they would have just ridden a wave in space-time to a distant future. The same is true for speed. Einstein's special relativity shows that the faster you move through space, the slower you move through time relative to someone standing still. If you took off in a spaceship at 99.9% the speed of light for what felt like 5 years to you, you'd return to an Earth that's over a century older. Your friends, your family, everyone you ever knew would be long gone. You would be a ghost from the past, walking in a future you were never meant to see. This is the famous twin paradox, and it's the first chilling possibility of time travel, a profound and irreversible isolation. You can leap forward, but you can never go home.
Section 2. Cracking open a door to the past. Okay, so traveling to the future is on the table. It's clean, it follows the rules, and while it might be lonely, it doesn't break the universe. But what about the past? What about going back to fix that one big regret? This is where physics goes from established facts to the deeply theoretical and the infinitely more dangerous. To go backward, you can't just bend time, you have to twist it into a loop. In the language of general relativity, these are called closed timelike curves, or CTCs. These are pathways in space-time so extremely warped that they could, theoretically, bring you back to where and when you started. Einstein's equations allow for these loops to exist on paper, but actually making one is a whole other story. One of the most famous ideas for a CTC is a structure known as a wormhole, or an Einstein-Rosen bridge. A wormhole is a hypothetical tunnel through space-time, a shortcut connecting two distant points. If you fold a piece of paper and poke a hole through it, you've created a much shorter path than traveling across the surface. That hole is the wormhole. Now imagine you could control one end. If you sent one mouth of a wormhole on a spaceship trip near the speed of light, time for that mouth would run slower than the one you kept on Earth. Step through the Earth mouth, and you could emerge from the other side not just in a different place, but at a different time, in the past. It sounds almost plausible, but here's the terrifying catch. To keep a wormhole stable and open long enough for even a single photon of light to pass through, you'd need something called exotic matter, stuff with negative energy or negative mass. While we've seen effects in the quantum world that can be described with negative energy, like the Casimir effect, we have absolutely no idea how to create or control it in the vast quantities needed. Early theories suggested the energy required might be astronomical, and even though newer ideas have reduced that amount, it remains far beyond anything we can imagine. Plus, many theories suggest these structures would be incredibly fragile. The moment you try to send something through, quantum effects might create a feedback loop of energy that destroys the wormhole in a catastrophic blast.
Section 3. The Grandfather Paradox and the Universe that Fights Back. But let's say you do it. You defy all odds, gather the impossible energy, stabilize the unstable, and step into the past. You've now come face to face with the most famous problem in all of time travel, the Grandfather Paradox. The setup is simple. You go back in time and kill your grandfather before he meets your grandmother. What happens? If he dies, you're never born. If you're never born, you could never have gone back in time to kill him. But if you didn't go back, he would be alive and you would be born, which means you could go back and paradox. The entire logical structure of cause and effect collapses. So what does the universe do? Does it just break? Physicists have a few potential and equally unsettling solutions. The first is maybe the most frightening for what it says about free will. It's called the Novikov Self-Consistency Principle. This principle, from physicist Igor Novikov, basically says that any event that would cause a paradox simply can't happen. Its probability is zero. It's not that some time cop would show up to stop you. The laws of physics themselves would conspire to ensure you fail. You travel back to kill your grandfather, but your weapon jams. You try to push him into traffic, but you slip on a conveniently placed banana peel. A bird poops in your eye at the critical moment. No matter what you do, your attempt is destined to fail. Or, even more subtly, your actions were always part of history. Maybe your attack is what startles him into the path of your future grandmother. You become the agent of the very past you were trying to change. You have no free will. You're just a cog in a pre-written, unchangeable loop. You can't change history because you are, and always were, a part of it. The thought that our every move might already be etched in the fabric of space-time is a wild one. If you're enjoying this trip into the physics of the impossible, do us a favor and hit that subscribe button. We explore mysteries like this every week, from the edge of the universe to the heart of a quantum particle. Section 4. The Chronology Protection Agency. This idea that the universe actively prevents paradoxes is so powerful that it led the legendary physicist Stephen Hawking to propose an even stronger version, which he playfully called the Chronology Protection Conjecture. Hawking's point was simple, and he put it best himself. If time travel is possible, where are the tourists from the future? He argued that the laws of physics are fundamentally set up to prevent time travel to the past on any scale we could actually use. His reasoning was grounded in quantum mechanics. As we mentioned, a wormhole or any time machine would be flooded with virtual particles that constantly pop in and out of existence. As a time loop begins to form, these virtual particles could travel through it and essentially overlap with themselves again and again. This would create a feedback loop where the energy density at the entrance of the time machine skyrockets to infinity, destroying the path to the past before it could ever be used. Essentially, Hawking's conjecture suggests the universe has a built-in defense mechanism. It will tear itself a new one to stop you from tearing a hole in causality. It's as if there's a fundamental law we haven't fully grasped, a cosmic chronology protection agency that keeps the universe safe for historians by making history unchangeable. While it's still a conjecture and not a proven law, it suggests the power to rewrite the past may be something the universe itself has wisely placed forever out of our reach. Section 5. The Terrifying Freedom of Many Worlds. But what if the universe doesn't fight back? What if there's a way around the grandfather paradox that allows for total freedom? This brings us to our final and perhaps most existentially terrifying possibility, the many worlds interpretation of quantum mechanics. This theory suggests that every time a quantum event has more than one possible outcome, the universe splits. Every possibility happens, each in its own separate parallel universe. So, if you go back in time and kill your grandfather, you don't create a paradox in your own timeline. Instead, the popular science version of this scenario suggests your arrival in the past causes the universe to branch. In the universe you came from, history is unchanged. Your grandfather lived, you were born, and one day you vanished into a time machine. But in the new branch you just created, your grandfather dies, and a version of you will never be born in that timeline. You haven't changed your own past. You've created a new, orphaned timeline that you might now be stuck in. You'd be a temporal refugee, an anomaly living in a world where you have no history and no possibility of ever having existed. You haven't just ended a life, you've created an entire universe with a causal break, an event with no origin within that reality. Now multiply that. If time travel worked this way, every trip to the past would splinter off a new reality. There would be infinite timelines, scarred by the actions of temporal tourists, an endless multiverse of chaos, all stemming from one person's decision to fix a single regret. Could humanity handle that kind of power? The ability to create and abandon entire universes just to satisfy our own whims? This isn't just a paradox, it's a moral and existential nightmare on an infinite scale. Conclusion. The journey through time is a journey into the very nature of reality itself. It starts with the lonely one-way path to the future that Einstein showed us. Then it descends into the theoretical abyss of the past, a path seemingly blocked by impossible physics and the unyielding laws of cause and effect. Whether the universe protects its history with an iron fist, or whether it splinters into an infinity of broken timelines, one thing seems clear. The power to control time might be a burden far too great for us to bear. Perhaps our biggest regrets are the very things that define who we are, and the unchangeable past is the anchor that keeps our reality from dissolving into chaos. So, I'll leave you with this final thought. If you were handed a time machine, knowing all the terrifying possibilities we've discussed, would you use it?